Okay, so what happens by looking at this from a more general perspective is that really, if the difference is positive, the op-amp spits out plus VCC. If the difference is negative, the op-amp spits out minus VCC. Now I'm going to try to prove that to you by doing a couple of these by hand. And I am assuming a super cool op-amp that has an open loop gain of 10 to the 8, which is 100 million times. So if I have a difference in my input, so this is my V2 has 2 volts and my V1 has 1 volt. So you see the difference is 2 volts minus 1 volt, which is 1 volt. So this VD is 1. Times that gain, the huge open loop gain, gives me 10 to the 8 volts. Obviously, my op-amp cannot put out 10 to the 8 volts given that I'm only giving it 10 volts power. So my output is clipped at 10 volts. Now watch what happens at the black line here. I'm going to do VD again, which is V2 minus V1. VD on the black line is 0 minus 2 microvolts, which is minus 2 microvolts. So watch, minus 2 microvolts. And now AVD is minus 2 microvolts times 10 to the 8. Micro is 10 to the minus 6, so this is minus 200. So this would have been minus 200 volts. However, the op-amp can't put out minus 200, so I'm going to go here. The negative power is minus 7. So this, I'll give you now a shortcut. If this guy is bigger, the output of the op-amp is going to be minus VCC. If the V plus is bigger, then the output is plus 10. So you can do the math on all of these. I'm going to go quickly through them. So look, this minus is the biggest one. I'm going to put minus 7. This minus is the biggest, minus 7. This plus is the biggest, 10 volts. The biggest meaning the larger of the two. 3, 10 volts. V1 wins, minus 7 volts. V plus wins, 10 volts. So I need you to practice on that and try to understand the comparator is always just comparing the inputs, the minus and the plus input.